M1 Statics example 12b. In this question, it appears that we're going to have to start again because the tension in the string has been changed. However, what we can do is look back at the calculations we did earlier and perhaps just change some of the values rather than starting again from scratch. So if we look at our expression here for R that we got earlier, the value for the tension was 15, it's now been changed to 10, but the angle hasn't changed. So this number is the only one that's going to change. So we can save a bit of work and we can just write down that the normal reaction will now be just the same, but it's now 10 sine 15 because this has been changed to 10 for the tension. If you work that out, it works out to be roughly 8.49, but keep the value in your calculator if you are going to work it out at this stage. If we now do the same thing going along the plane, we actually know from our value here of R that we can work out the friction because the coefficients of friction will be unchanged, and so friction will be 0.47 multiplied by this answer that we've just got for our normal reaction. And if you work that out, it works out to be approximately 4.01. Again, keep the full value in your calculator. So we now know the value of this frictional force, and the question is, determine the magnitude and direction of the force of friction in this case. Well, we've worked out its magnitude is about 4 newtons, but what we need to work out is which way it would be acting. So what we need to look at is the other forces that are acting in this situation. And if we go back to, again, this line here, the only thing that's changed, this is friction, and we know that that is 4. So what we can do is we can say that we have 10 cos 15 minus 1.6g sine 45. And if you work that out, that works out to be minus 1.428. What that means is that the maximum possible value of friction you could have in this case is around about 4 newtons, but we don't need 4 newtons because the forces that are acting on this object are not pulling it to a situation of limiting equilibrium. So we actually only need 1.4 newtons of friction. We don't need to use the full limiting equilibrium value of friction. And also because we got a negative, it means that in our calculations earlier, the friction is acting in the wrong direction. So rather than acting down the plane, in this case, the friction will be acting up the plane.